a new way to generate unlimited solar panels on the moon using no water and creating no waste. A new sunscreen that'll help combat coral bleaching. This and more coming up. Welcome to ChemBites, small bits of chemistry-related news brought to you nearly weekly. So first off, we'll go with updates. Cubane supplies are going to be in next week, so I'm going to be starting with that again. I pretty much had to start over, exhausted my options. I have some good ideas coming up, so hopefully we'll have a good result with that. Either way, I'm going to post a video on the results of that, and hopefully it's a success story and not a cry for help, but it may be, a call for the community to step in, and we'll try and figure this out, because it's been fighting me. Then we just did our electrolysis video, and we have quite a lot of skepticism going on, and I think it's warranted. I share that skepticism. So I decided to send my sample in to get an NMR. So we're going to get a confirmation on that. Is it nitroethane or is it not? So this first story really interested me because it combines two of the things that I love the most. This and this. So Blueorigin, with the guy who thought it would be a great idea to hitch a ride into space while the world was suffering with a virus. Space. So anyway, they've revealed a concept to create solar panels exclusively on the moon using only moon materials with pretty much limitless potential. This utilizes the regolith on the moon, or the moon dust, as it goes along with the idea that our new moon colony should be nearly self-sustaining. So they've termed the project Blue Alchemist, and it uses no water and creates no waste. It's a bold statement. So first they're creating a robotic autonomous machine to collect the regolith and put it into airtight compartments. Now regolith is rich in iron, aluminum, and silica, which the silica is mostly what they're going after. However, the problem with this is that nearly all of the molecules in the regolith are bound to oxygen molecules. So they need to find a way to separate that oxygen molecule out. And the second issue is to manufacture a solar panel, you need 99.9% pure silicon. So they're using a process termed molten regolith electrolysis. So my last video touches a little bit more on electrolysis, but just for a really quick recap, it uses electricity to separate molecules out of a solution. The idea with this molten regolith electrolysis is it will pull the oxygen molecules off of the silicon. So electrolysis requires a liquid state, and since they plan not to use water, since water is a rare commodity on the moon, they'll need to melt the regolith. So with several different recipes of simulated regolith, Blueorigin went and melted this regolith down and shot a bunch of electricity through it, and it worked. They claim that the process went extremely well, and they also claim that the liberated oxygen can be used towards life support systems. Next comes the hard part. They're going to need to actually manufacture the panels, and unfortunately they are keeping their developments on this process mostly quiet. They're claiming to be developing a machine that will autonomously manufacture these solar panels. It will have a 10-year lifespan, and it will create no waste. So given the massive delays on the BE-4 engines and the New Glenn rocket, I need to remain pretty skeptical here. I think it's extremely exciting that they've found a method to manufacture that pure silicon from just the moon regolith, but I think the hard part is ahead with the actual manufacturing process. I really don't see how they can do this without generating any waste products, but if this can move forward and they can make it work, it will be huge for a moon colony. Solar is going to be pivotal for our moon colony, and I think we're also going to see a lot of smaller nuclear reactors for power as well. I think it's just nice to see chemistry growing beyond planet Earth. Next, researchers claim to have found a potential new way to create an eco-friendly sunscreen that's even more effective than any of our existing stuff. Lei Tao from Tsinghua University was inspired to research new sunscreens after he visited the Great Barrier Reef and learned that one of the primary causes for the coral bleaching is actually sunscreen. The process uses polymerization to create molecules that are small enough to block UV light but are too large to pass through the skin. These molecules are also too large to pass through things like coral and algae. Researchers stated that by performing reactions to randomly generate ring-shaped molecules, similar to avobenzone, which is an existing UV filter. After this, they performed a second reaction to link all of those ring structures together into larger molecules, and they formed several different candidates. Using lab mice, they tested these candidates against an existing product and found that one of them was actually better than the existing product. I think it's a really interesting finding, and I'm hoping to see more of this project in the future. One thing I did notice, though, is that the candidate molecule that they state in the paper is not biodegradable, so it's kind of counterintuitive for protecting the environment. Tao stated that they have an array of other candidates that they'll be testing, and they're also working with different companies to scale up that testing. That's going to do it for this video, guys. Thank you so much for watching. If you'd like to follow some more stories and experiments, feel free to like and subscribe. I've started a new Patreon with a link down below, and I'd like to extend my greatest appreciation to all my existing Patreons. And with that, we'll see you guys later.